Okay, so today what we're going to have a look at is finding the shorter side of a triangle using Pythagoras' theorem. So again, we've got our right angled triangle and we've got A, B and C. And we know from Pythagoras that A squared plus B squared is C squared. If we already know the hypotenuse and it's not the thing we're trying to find, all we've got to do is rearrange the equation. Okay, so we just need to find, if we're looking to find A or B, we just rearrange the equation. So here is my original, A squared plus B squared equals C squared. So rearranging, I can take the A over to the other side, so C squared minus A squared equals B squared. Or if I want to find A, I can take the B over to the other side and I get C squared minus B squared equals A squared. Now you don't need to remember those. Because you all know how to rearrange equations, the best thing to do is to actually rearrange it once you're involved within the question. So here is my example for you. So here's my right angle triangle. No, it's a right angle. It's got a little square there. My hypotenuse I'm given is 28 centimetres long, and one of the sides is 10 centimetres long. So I'm looking at A, B and C. Just remember how I'm labelling my triangle. So A squared plus B squared is C squared. So I'm going to substitute in the values I already know. A, I've said, is 10, so it becomes 10 squared. B is x squared. And C squared, my hypotenuse, is 28, so it becomes 28 squared. So the first thing I'm going to do is rearrange it. I want x on its own, so I move my 10 squared over to the other side of the equation and it becomes a minus. So x squared becomes 28 squared minus 10 squared. Work out what 28 squared and 10 squared is. That's 784 minus 100. So x squared is 684. Final thing to remember, I have to take that square root. So I take the square root and x is 26.15 centimetres to two decimal places. Sorry about that. Remembering, of course, that I have to include the units and I have to state how accurate I have rounded my final figure to.